good morning, everybody. Welcome back to the Applied AI in Logistics conference organized by Advantage Austria, my organization, and
AI Austria, our organization. Yeah, welcome back.
Clemens, we had a pretty exciting day, full of presentations from the logistics industry and from innovative AI companies yesterday, and we continue on today.
Yes, exactly. Today we will have a few of the largest Austrian companies here. For example, we will have the Austrian Postal Service in the morning. Then we will have the ÖBB Rail Cargo, which is like the state-owned or the national rail enterprise in the afternoon. In addition, from Europe, research powerhouse Fraunhofer is joining. And yeah, last but not least, a very special guest from Korea, where you spent, I think, half of your professional life.
That's right, and I'm very happy about that. Our speaker that joins really from another time zone. It's almost in the evening now in Korea, right at the end of the working day. Well, probably going a little bit longer than 6 p.m. But until we welcome him, let's check a few housekeeping rules for this virtual event of ours. It's all live. What you see now is actually what is happening now. We didn't record anything. And the beautiful thing about live events is that you can actually interact with us and interact with our speakers and also interact among yourselves. How do we do that? Well, let me pick it up. There's, of course, the possibility to use Slido, our chat function. If you are actually logged in here from on the B2Match website, you see a Slido window here on the right where you can ask questions. Or if you are joining from LinkedIn, you can get out your smartphone or open another tab on your browser and head over to slido.com. At slido.com, you enter the code AAIC log 21 to join our Q&A session. And right now we have a poll running on Slido, and we are going to take a look at that quickly because we are actually asking you from where you are joining from. As we all know, the current situation is already lasting for a year, and we are right now in our studio, but usually we are also in the home office, and we also wanted to know where you are joining from. Let's have a look. Well, around 70% of you are actually joining from the home office, which is not surprising, but already 30%, almost a third of you are back in their normal office, which is quite interesting. And somewhere else, well, maybe you are on the commute, maybe you are in your car, maybe you are on vacation somewhere. All good. 4% of you join from somewhere else. That's also good news.
Yeah, then when it comes to the agenda, we made 3 modifications since yesterday. The first one is we now have an additional use case presentation in the time slot exactly at noon, Central European time, between 12 and 12:30. That will be about demand forecasting in logistics from Austrian startup 7lytics. Then directly afterwards, the two of us, as the organizers, will give you a brief overview what we have planned on with regard to future events this year. There are quite some. We also added this information in the video loop that is playing today. And last but not least, there will be a workshop hosted by one of our partners, Exilium. They host the afternoon session today. This workshop will take place tomorrow morning from 9, if I'm not mistaken. Yeah, you're sharing it.
And if you're wondering what is going on today, what will go on later, just head over to our agenda on B2Match. We will share the link on LinkedIn right now so that you can just have a click and have a look. All right. And you see the agenda for today. It should be in your time zone. For us, it's the Central European time zone. And make sure to not miss the part that you want to have a look at. So, and I see we are already having a connection with Seoul, South Korea. Let's welcome our speaker, Myung-Han Kim. He's the CTO of Mesh Korea, a dedicated unicorn company in Korea dealing with last mile logistics and AI solutions, specifically for last mile logistics. Hello, Myung-Han, can you hear us? Wonderful. Let's check the connection. Maybe you have to unmute your mic. And yep, now we should be able to hear you.
All right. Perfect.
Wonderful. Perfect. How is it going? It's 6 p.m. in Korea. How was the day so far?
It was always busy day, like always, and then now I'm going into the end of the day, and I'm very excited to be here and thank for the opportunity as well.
Yeah, we are very happy to have you, and we have already a lot of people logged into LinkedIn and into YouTube watching the stream. I would give over the stage to you. We already have your slides here. And during the presentation, you can ask Myung-Han any questions that you like. We will answer them in the Q&A session in about 30 minutes. All right, Myung-Han, the stage is yours. Talk to you a little bit later.
Thank you. Hello, everyone. Thanks for attending this talk, and I'm very happy to speak about our company and the AI for logistics. And I'm the CTO of the Mesh Korea, which is known for the Vroom brand. And before joining here, I worked for LinkedIn, and I work for people you may know AI algorithm. So I'm very engaged with this AI world since before. So let me introduce our company and last mile logistics first, and then let me show how we start the AI for real-time delivery dispatch as a case study. And for the final agenda, I will share some practical tips for applying AI to general industry as well. So let me introduce our company first for the people who are not familiar with our company. So our company provides a Vroom service, which provides F&B deliveries like Burger King, McDonald's, and Baskin-Robbins, and many franchise restaurants. As well as we also deliver goods. KT is one of the largest telecom company, which delivers iPhone or the Galaxy phone for the users. So if you order cell phones in 1 minute, then we deliver them in 1 hour. And you may know the Blue Bottle copy. We also provide a cold chain, the supply chain for the Blue Bottle, as well as we also provide some HMR commerce using trucks and other forward vehicles. In addition to logistics service itself, we also provide logistics IT solutions as well, like transportation management system, TMS, and we provide the algorithm as well as all the BI systems. We also provide the BI solutions for delivery, restaurants, and some other customers as well. So in overall, the Vroom provides a total digital IT logistics service, including many IT tech systems like order management system, transportation management system, and so on, as well as we also provide the workers and all logistics infrastructure like warehouse, transfer center, and so on. So we call it as a IT logistics BPO service, business process outsourcing service. And our company is almost one of the top companies in this area in Korea. So let me introduce last mile logistics service. Of course, you may know what is last mile, but for people who are not familiar with this term, let me briefly explain what is this. So to deliver or to provide goods from producers to the consumers, you have to deliver these items from factories or any processors, and it transfers through some warehouses and then delivered to the final customers. So we call the first segment from producer to the warehouse as first mile, and all the segments between among the warehouses or the centers as a middle mile. And for the final segment, from the final warehouse to the end consumer, we call that segment as last mile. So take a look at our business and the industry right now. So previously, all the logistics focused on scale and the large volume transportation and its operation and management. But nowadays, it has changed. Now, many people and many industries and many consumers are now focused on their own experiences. So the one-day delivery or even the several-hour delivery, so they care, the consumers care. So now all the logistics start focusing on the consumer's experience, not just scale or volume transportation. So because the consumers are involved in the last mile, so last mile logistics has become more important than before because that experience is the critical in this area. So to change the diagram, so previously logistics usually spend energy on the establishing large infrastructure and large facilities and so on. But nowadays, it's not enough because to provide the various experiences and speed, you have to equip so many things. You have to visualize so much capacity. Because of that, the service platform has emerged, and now our Vroom also runs a platform, so that many number of participants, like riders and the various managers, they can join our platform, and we provide services. Then our key KPI may be different. So previously it focused on the massive infrastructure investment. Nowadays people focus on the diverse platform user, including riders and the restaurant owners and so on. Their retention becomes more important. Unfortunately, this last mile requires a lot of resources, and last mile is one of the cost intensive segments. It's because typically per order you carry a small volume and you have to deliver to many locations. It requires resources and so on. And practically, it's the local policy, like a regional policy, is applied to each last mile logistics, and because you have to touch the last end user experiences, you need various task management, and you need a high service because you touch the end customers and so on. So naturally, last mile logistics includes a lot of challenges. So as I said, our service and our company is providing platform, and we are running the logistics service platform. They're like general platform services. Logistics platforms also have the following three great challenges, which is variety, velocity, and volume. So you may have heard these three phrases from the big data era to this AI era. So the variety means you have to provide a localized experience, and you have to deal with the diverse flows and diverse vehicles and neighbors and so on. And our market is changing very quickly. You have to follow with this high velocity. Also, logistics also require the volume and which produce efficiency. So you have to deal with also a lot of deliveries and clients as well. And you have to deal with these three challenges. You have to solve these three challenges economically. Otherwise, your business will fail. In this talk, I will more focus on this variety part and the volume part. And focusing on this part, so you have to deal with a local experience and your orders are changing quickly and your market changes and you have to deal with the different labels from the beginners to the experts. Therefore, particularly for the beginners, if this kind of variety exists, then their job will usually fail because they don't know how to deal with all other kinds of the requirements. So here, let's simplify the mission here in this talk. So our mission is to simplify and clarify the task requests so that even beginners can handle the jobs. For example, for the restaurant deliveries and the food deliveries, there are many requirements and you have to deal with many flows. But it's harder to the beginner. So we want to simplify and clarify the task even for the beginners. So then, to simplify this task, we started using the AI, and let me introduce how we apply. So let me explain a little bit more detail about our on-demand market. So as you expected, it's a real-time order system, and you have to pick up order and deliver order. And unlike many other systems, our on-demand market requires multi-pickup and multi-drop for the productivity. Some of you may know that Korean market already had shaped this delivery market for a long time. So there exists a lot of riders even before, and there has been already stable market for the delivery. So in that case, already people carry the multiple items and then deliver to the multiple houses even since say 10 years ago. So we couldn't, we cannot break this productivity, and we have to deal with this productivity so that we allow the multi-pickup and multi-drop. Then, which means that you have to plan, okay, which pickup I should go first, and which drop place I should go first, and okay, for the given orders, if you received a lot of orders in the queue, then you don't know whether you can handle that or not. So here, to simplify and clarify the task request, you have to assign the proper the order to proper riders, and you have to give the recommended plan to the people. Otherwise, let's say crowdsourced workers, usually they are beginners, they are not experts, then they don't know, okay, which order is proper to me, or which order gives me the more productivity so that I can earn more money. So if you have experience, it's maybe easy, but if you don't have experience, it's very hard job, then even for the same kind of task, you earn less money. So if you have operators, you can assign this task to each beginner. But if you have a lot of deliveries and a lot of orders, then you have to hire too many operators. Then our goal for the AI is how can we change this operator job to AI? So before this AI-driven order dispatch, it was a queuing system. So in some region, if order is received to our system, we send this order to the certain queue so that all the regional riders can see the orders. Then each rider should see all the orders and picks up one proper for him or her. But it had many downsides because we want to riders to provide the best quality services, and the riders who provide the best quality we want them to earn more money. But in this case, the salary is sensitive to how to plan your orders and how to pick up proper orders. But we don't want that situation because we want the high quality service to the end customer. Then AI can solve this problem so that we can properly assign each task to each rider. Let's say I specify the problem here. For a given order, we want to choose the best rider to provide the best services. But here's the problem. So we want to use AI to solve this problem, but we don't know which one is the best measure, or we are not sure about what is the best objective. For example, you can use the expert's preference or expert's opinion, or rider's preference, or you can think of delivery time as well. Or sometimes people want the fairness. Okay, please let's have an equal assignment to each rider. And we have certain kind of SLA to the restaurant that we may want to optimize for the SLA violation. So here's a big problem. So in our case, when we started this AI-driven order dispatch, we adapted the following strategy. We first use the rider's preference as a top objective, and we roughly touched the SLA violation, and we briefly touched the fairness problem. So let me explain why we made this decision. So let's think about this way. So we allow the turning on this AI-driven order dispatch as well as turning off this AI-driven order dispatch so that we provide the options for riders to configure. Otherwise, we have a labor compliance problem. So in this case, business people can think this way. If riders don't adopt this system, then it cannot succeed. Then our first necessary condition to make the success for this problem, it needs adoption. So okay, then AI model thinks that strategically, let's focus on recommending acceptable orders to the riders, so that as far as not hurting the productivity or service quality, so that riders can adopt this system, then we can gradually improve the other parts like fairness or delivery time and so on. Then we want to model how riders selected these orders in the past so that we reflect their preference, but we also use the other characteristics like SLA violation and time constraint as features. So we use the which order each rider selected before as a response variables, and we use other objectives like fairness and so on as a feature, so that we can combine them intermingling. Okay, so we use the past data, and as I said, we formulate this as a classical classification problem, and we use that as an inference, and we selected the rider who has the highest score. This is a brief architecture of our system. We use PyTorch, and we use the AWS system. We run the MSK, the Kubernetes, and we have the microservice inside that. We use the PyTorch inference system, and we run the A/Test platform to configure the model and test the model and select the model which wins over the other. And here's a more sensitive part. So because of this delivery, typically the riders are very sensitive to a little bit of the income as well, because they are living with this small income. And then the performance of the algorithm may impact their salary. So it's very sensitive. So because then which means that our field or the experiment, or online experiment is very expensive. So we have multiple layers of the evaluation system. First, we use the conventional evaluation system. Then we run the unit test as some infeasible cases, like so that we don't want to give the the infeasible cases like oh, please go to the 5 kilometers in 1 minute, something like that. So we want to avoid that kind of case. And we have some goal. We run some gold standard small labor cases by the expert, so that oh, in this situation, yeah, this rider should be picked up. Yeah, we have that kind of gold standard, and we run some small random cases so that okay, let's start some small random case, then let's see whether our model selects the proper one or not. Then we run some dark state test, which means that we deploy the model to some dark traffic, so that okay, we run the event, we face the live traffic situation, but we only evaluate the model, but we don't actually solve the traffic using the new model. After all the tests pass, then we wrap with a small percentage, and given the experimental result, we deploy more and more. As a result, we improve the productivity by 11% quantitatively, and we reached over 80% adoption rate in the testing region. And qualitatively, so people talked about safety, and it provides a fair, income distribution, because it doesn't, it has nothing to do with someone's, opinion, and then people also said it's efficient. Okay, so this delivery, I talked about this for a given order, choosing the best rider as our problem, but actually for the delivery dispatch system, there are so many problems we have to solve. I just touched on one case. So we touched the selection case, but actually you have the dispatch control, so you throttle the dispatch rate, and then so you also have a candidate, and you have to predict the time, estimate time, and so on. So you have to deal with so many problems, and that all these problems require AI to tackle those problems. And finally, let me share some practical tips for applying AI to industry. So here is the recommended main assumption. I always assume this, and then I will enforce this assumption to all the AI modelers and AI engineers here. So you don't know the actual business impact or business performance of your model until actually it's applied to the real world. You have definitely lab test, and you have the evaluation system, but many cases the evaluation metrics is different. You may face other real situations, so you don't know. So you have to stay always hungry, but you also have to stay humble. So let me share the 3 kinds of tips. First, please shape a continuously improve business problem. So let me show some example. So here's a smart reply, which recommends 3 kinds of the short the dialog messages to select. And here's a chatbot. So both require the similar kind of NLP technique, but one product is easier to succeed than the other. Because smart reply requires only, let's say, the 50% of prediction accuracy is good enough to succeed. But chatbot, even if it has 80% accuracy, the consumers will have some bad experience. So you have to apply, or you have to shape the problem so that your service can survive even if AI model just improves the baseline. If it will be fragile if you apply the AI model to your service fails if AI model does not meet the high threshold. And What you want to in business is typically not an AI model. Often what you want is somewhat vague, sometimes hard to measure, and typically not evaluated by actual the standard AI method. So my recommendation is instead of using the too sophisticated the model or build a sophisticated model with a lazy objective far from your goal, instead of that, please use a usable model for the custom objective perfectly fitting to your goal. Finally, please establish a productive and iterative process. For the building the sophisticated model or the academic model, sometimes it takes a lot of time to run the batch training. But industry is a process, iterative process. So setting up the robust continuous improvement process is more important because you earn the more gain over time, even though you have a lower gain in the beginning. Okay, finally, so AI can provide this productivity problem, tackle the productivity problem so that you can scale and then it solve your problem instead of a human. Then human resource will remain. Then you can employ the human resources for the human being themselves. So AI automation can help the human. Then human can focus more on the qualitative research, which means that you can provide better human-to-human services than you focus on just operation problem. Okay, this is it, and thank you for listening to my talk, and please share your question. Thank you.
Thank you so much for the exciting presentation. Can you just go back 3 slides? We really liked the one slide. Yeah, there's this one here. Actually, everybody, you can make a screenshot of this one, but we will share the slides later on. What you want in business is not an AI model. It's often vague, it's hard to measure. Really interesting. And we received a lot of questions, and we quickly want to go through them with you.
Yeah.
Everybody, you can still upvote questions or ask them yourself. So let's see. Okay, a cultural question. How do drivers accept being remote controlled by an AI? Can you say something about this?
Yeah, this is a very sensitive issue. Yes, we also have a labor union in our company. We don't have a labor union, but we have a general labor union, and some company also has a labor union, and sometimes it has a conflict with the labor unions, and also it's sometimes sensitive to the labor compliance. So here's the thing. So as far as we give the value to these writers, they are usually accept this AI. For example, if they think, as I showed the qualitative result, if they feel safe, because you don't need to see all the order cues while driving, then they feel safe. They are okay with and pleased with this AI system because it doesn't hurt their salary or income. So as far as it doesn't hurt their income, they are usually fine. So, but of course, there is some political conflict with their manager or their operator because they want to, sometimes they want to operate their team members, and sometimes they want to govern their behaviors. Of course, we have that kind of conflict, but for the writers, as far as we give the value, they are usually fine.
Very interesting. And related to that, another question that I just quickly like to pull up does this mean using your technology, delivery companies can use more inexperienced drivers?
Oh, yeah. Oh, actually, that's a very good question. And that's our main goal of this AI system. I also tried the deliveries using the bike. not motorcycle, the bike. And I tried it. I have this field experience, and actually I faced the exact that problem. So I didn't know how to select my order, and then I have a little information about okay which one exists. Of course, I can see the map, but once you see the map and then okay think for a long time, that your goal order will disappear. So I exactly faced the problem. Then my productivity, I could only just carry 2 orders in 1 hour, which is below the minimum salary.
Okay, below the minimum salary. Okay, quite depressed.
So you have to deal with the 3 orders, and it's 3 orders in 1 hour. Otherwise, you will earn the less than the minimum salary. Then actually, the how to plan your order and how to pick up your order is very critical. So that's why we want to solve this AI problem and share this AI service with these beginners. Then we can provide this AI service to the crowdsourced workers, and they can earn enough money, and we provide the experience to the beginners through the platform.
All right.
So we have time for one more question. That would be, would your system also work in urban areas with less density?
I mean, less like Seoul is not difficult, but like in Europe somewhere.
So, okay, this is a very good question. We also have some, of course, our testing area, obviously our testing area is somewhat dense, the urban areas, that's true. But it actually, it makes the problem harder than the rural area, because in the rural area, you don't usually, pack the multiple orders and pick up multiple orders and drag multiple orders. It happens because it's a dense area, because it's possible. In the rural area, in some less dense area, you just pick up 1 order and you drop 1 order, and we just need to just stream the order instead of the packed orders. So I believe that it's perfectly fine, and it's more operational problem or the hiring problem than the AI problem.
So thank you so much for this presentation. We are at the end of our time slot already. I hope you stay around for 1 or 2 meetings in the B2B meetings. If you want to talk to Myung-Han, please feel free to reach out to him and Mesh Korea. Also, you can find him on LinkedIn. And well, best wishes to Seoul.
Yeah. Thank you very much.
Thank you.
Have a good day. Bye-bye.
Bye-bye.
So after a brief video roll announcing the next speakers, we will be back in 2 minutes. So stay tuned for the next talk soon.
Talk to you in a bit.
And we're back for the second speaking slot of this morning. So with us, I welcome Mr. Patrick Radeiser from Left Shift One. Hello, Patrick.
Hi.
And Mr. Matthias Hoffmann, EVP at Austrian Postal Service. Hi, Matthias.
Hi.
Hello. Yeah, maybe few introduction words. LeftShift1 is one of the fastest growing Austrian AI startups. It was also included in the Forbes ranking for the DACH region. It is, this AI 30 list. And today they're sharing the stage with one of their customers in the logistics space. That is, from the Austrian Postal Service. So we are looking forward what you're going to tell us. As far as I remember, Matthias has to leave at 11, so the Q&A session later on will be handled by Patrick from LeftShift1.
Thank you.
Thank you. Just for housekeeping. And as usual, if you have any questions, please mention them on Slido. We will post a link. And looking forward to your talk. Enjoy.
The stage is yours.
Thank you very much. I start the presentation. So it's fine. Good. You see my screen, hopefully, the full screen. Good. I will start. My name is Patrick, and I'm the CEO of LeftShift1, and my partner is Matthias, who will give an insight in his logistic use cases. The presentation is focused on how to get ready for a more productive logistic environment. But before we start, we will take a short look at the AI market in general and how many projects are in production. Good. The size of the AI market is currently more than $156 billion with a compound annual growth rate of over 17%. That sounds awesome for companies like ours, and it is an indication that we absolutely have to deal with the topic AI in future. Furthermore, AI will help companies to reduce costs by billions of dollars every year. So I guess you could say this is a wonderful vision for our industry. Welcome to a brave new world. But 80% of all AI projects do not make it into production. So in the next 10 or 12 minutes, I will provide you with an overview and what you can do to ensure that your AI projects are successful. Afterwards, Matthias will give us an insight regarding the project in his company and how they have dealt with AI projects in the past. So with this in mind, let's have a look to the big 7 in order to make AI productive. Firstly, be agile and meet the expectations of your AI project. Okay, so for years we have been using agile software development for software projects. However, we believe that approach should also be used for developing AI projects. The reason for this is because we need iterations as well as feedback cycles when developing machine learning models. But now from our daily working experience, we have seen the waterfall approach being used again and again, especially in relation of AI projects. Of course, companies are constantly seeking to minimize risk and believe they are on the safe side when they're choosing waterfall fixed price projects. But 50% of all requirements in a software project tend to change over a period of 1 year. This is being the case. A company will define an AI project, and then at the end of the project, the company wonders why this project hasn't met the expectations. From our experience, unfortunately, we see waterfall project in AI as well. In order to meet the customer's expectations, many change requests are requested, are issued by the clients before the client states that the project it's okay. It's clear that the customer is unhappy with the overall results. However, they are satisfied enough to close the project. So this should not be the case. So the reason why the most projects do not make it into production is due to their complexity. And because often take too long to receive early feedback from the client. So what must be done to be successful is to reduce the complexity of each function and to be quicker with implementation in order to achieve earlier feedback. So we should be working and dealing with minimum viable products in an agile way. We should start with one use case, then do a short data analysis, and then define the goals. My philosophy is just do it, fail fast, be successful, and meet the expectation. I can assure you that our company will learn significantly more in a short amount of time using this method. And by doing so, your business will become better when dealing with AI project and start the next use case as quickly as possible. So go to the next topic. Let's go in detail for hyper MVP. So hyper minimum viable product. A typical MVP is a product or service what can be used in a realistic environment. With dealing with a minimal implementation for qualitative feedback of your product. Hyper MVP is defined with only one use case in a defined minimal time. So firstly, when we're doing a hyper minimal product, we start with the kickoff meeting to define the general conditions and requirements of the project. Next, find some overall use cases that are wanted to be taken care of. In the workshop, it takes 2 days. We will define 3 use cases and the goals or KPIs that must be achieved. Then we bring them in order and define the priorities of each case. The most important part in this phase is to define the specific goals and KPIs. The goals are reduce costs or increase quality or quantity. Afterwards, we choose that use case with the highest business value. From our daily working experience, we know that step are something that is missing in a lot of AI projects. And that is the reason why they fail and do not go into production. In the next step, we have to do the data analysis. We know what the expectations are from a data perspective, and that is to have a lot of data. But this is not really the truth. It can be achieved with a smaller data set as well. It depends on the solution, what we want to achieve. Once a use case definition and the data analysis is completed and the project goals have been defined, then we will be ready to implement a hyper MVP in only 30 days. Of course, we can't integrate the whole solution in the internal infrastructure, but we can create a product which can be evaluated. By doing so, we learn from the beginning how to deal with these approaches. We have a result in a very short time with fixed costs in order to reduce the risk. Good, let's go to the business value. A deeper insight. Artificial intelligence is often said to just be a hype. So in order for AI to be used more frequently in project, it has to be able to create a value for a business. When we go a little bit deeper, we have 4 goals to achieve and 1 purpose. The first is increase the output volume. The second is increase the quality of your processes. The third is reduce the cost. And the last one is to create new data-driven business model. Finally, our purpose is to increase the productivity as much as we did in the past, when you remember in the Industrial Revolution. So the goal of using AI is to increase over all levels of productivity from the beginning of a project until the end. In the beginning, you have to invest in your AI applications. However, your risk will be kept low if you use hyper MVPs. So if your use cases are created across the whole value chain while using AI, that will increase productivity as well. After implementation, more use cases, you will have the advantage of economy of scale, of scope, and your company learn how to deal with applied AI, as well as being faster and more efficient. To minimize your risk, even further, you can also use open source frameworks or AI platforms, or choose an AI consulting firm from the beginning. As a result, your initial investment will be significantly lower than the amount of costs you save, which will increase your return of investment. So a short part of data, when we're talking about, we have to talk about data quantity and quality. So the amount of data has been said to be essential in the context of AI, but it's not always the case. When we think about big data, if the data is unstructured, it is unusable. You need structured data to train a machine learning model. Of course, you don't need it if you want to identify a cluster in unstructured data set. However, when we think about new approaches such as we heard, reinforcement learning, the framework conditions are important. When we consider 1 or 0-shot learning approaches, there are a lot of powerful open source frameworks and pre-trained models on the market available. Of course, these approaches all use data. However, these machine learning models are pre-trained and can be used for a variety of projects. So the required data always depends on the issues or problems we wish to solve. So let's talk about the data quality. it goes without saying that the quality of data is the key of any project. As a consequence, we have to delve deep inside of a data set in order to analyze the distribution, the features, the bias, the balance, and so on. I will give you an example. For example, there's a lot of data when we want to forecast the impact of a meteor as 10,000 tons of rock fly past our planet on a daily basis. However, it's not necessary to know how many meteors fly past each day. We simply want to know which meteor is a threat to us. In this case, we need to generate data using data augmentation to balance the data set to find the one specific dangerous meteor. So in this example, quantity is not an important fact. Rather, it is the quality of the data which determines the result. Yeah, the next point, a big thing, the topic algorithm. So far, we have learned that the amount of data is not the important or the most important factor. And from this perspective of an algorithm, the same approach is used. Indeed, artificial intelligence has been around for over 60 years. So there have been countless excellent and efficient approaches from algorithms of the past. We're talking about applied AI, and now it's usable. So we can use decision trees, support vector machines, or even simple regression or statistic models in order to achieve our goals. Therefore, if we have more data or pre-trained models, we will be able to use neural networks or deep learning as well. So we have to use the right algorithm at the right time, or even combine different algorithms in order to be successful. What does that mean for us? We can and have to start. That means just do it. And now, Matthias will show us how his company deals with AI projects. So Matthias, it's your turn.
Thank you, Patrick, for setting the stage. As you can imagine, logistics, it's not only moving boxes from A to B, it's always correlated with not only the goods flow, also the information flow, and we gain a lot of data along our supply chain and along our value chain. And we are constantly thinking of use cases, how we can either monetize or increase our productivity based on the data. And artificial intelligence can be one answer to this challenge to achieve those goals. And I brought three really different from each other use cases to give you an overview of what we're doing, where we are successful and where we are not successful, and what we're learning from our failures. Let's put it this way. Next slide, please, Patrick. The first use case is some really postal business specific field in the field of automatic postage machines. Maybe you know those automatic postage machines. They're in place in small and medium companies, especially, for example, in lawyer offices. These machines are connected via the internet or the telephone line, the landline, and mail, like old mail, physical mail, is weighted there and counted and billed. So we rely on the correct working mode of these machines and also the connectivity. We have, let's say, dozens, it's not hundreds, but dozens of machines in the field. So we gain a lot of data from these machines, where we had a look on that with algorithms and artificial intelligence to predict the volumes, let's say a demand forecast, like we stated here. And we tried to learn something from that to find outliers. And indeed, if you go to the next slide, indeed, I brought you an example from the timeline. Each line is one machine. And we found out that specific machines of specific companies and in specific seasonalities tends to produce errors. They either don't transmit the correct amount of letters or don't deliver any data, but they're supposed to because they did maybe in the months before or the year before And so we found out that some machines were not working properly. So we detected an error in the machines, so we could replace them with different machine types. And we also found out that some of the machines didn't bill the letters correctly. So we also closed some revenue leakage. This worked fine. It's on a very small scale, very specific use case. But if you connect the dots, it's data in the field of machines, a lot of data available, and I think this can be used everywhere where you have the same prerequisites, not necessarily the postal business. Yes, finished and successful. If you go to the next slide, as you can imagine, high parcel volumes and also the letter volumes are a challenge for our network as a logistics company. So we set up a model a couple of years ago to try to predict our volumes which need to be sorted and delivered in our sorting centers and delivery depots. We set up I would say good working model based on algorithms. We didn't develop an own algorithm, so we used algorithms available on the market. This is also a takeaway maybe for you, that you don't have to invent everything by yourself, especially if you're not that firm in IT and artificial intelligence in general. So there are a lot of off-the-shelf solutions available. So we had various input parameters in the first batch. And we saw that all over Austria, the predictions were pretty good. Let's say single-digit percentages of failure. But the more detailed we looked on our, let's say, sorting centers and depots, the error got bigger. And this should have been an alert signal where we should have spent more time and put more supervision by our experts, by our logistics experts in these models, and define our feature set, what I said before, the input parameters, more carefully, and put more time and more attention on that. And if you go on the next slide, you see our network, and Patrick can second that. I think the smaller the scope is, it's statistically proven that the error gets bigger if you don't strengthen your feature set. And this happened here, and we lost, honestly, the commitment and of our experts and our internal clients and customers to use this model. So we, let's say, are not using this model on a depot level, and on the sorting center level, we use it on a global level for volumes all over Austria. But what we wanted to achieve, we didn't achieve. And what we learned from that, our takeaways from that is, in the future, if you set up a new model, and we do this, we set up a new model for that. We need the commitment of the experts. We need the supervision and the knowledge of the experts. We need more time and more brain for setting up the feature set, let's say the rules, how to predict volumes, and then it will work for sure. So, and then the last, the third use case is something for the future. We kicked off this project. We call it the predictive fraud detection. And what we want to do is here give our team of experts a tool at hand to see and get alert signals if customer claims of specific clients correlated with specific, let's say, clustering in depots, in delivery regions, and across all our data and feature sets we have to have an outlook if there's something going on, if there's some fraud, and if we're losing parcels with high value. And it's not only a good use case for us to close this leakage. It can also be a new product for e-commerce retailers and clients, so we can give them a risk management tool at hand if they're starting. If a client is starting to check out or in the e-commerce shop to buy something, and in the checkout process, we could give them a risk management tool at hand to say, okay, we saw in the last few weeks there is some risk indicator of X. You should take into consideration that it should be paid upfront, for example. This is for the future, is to be started. It's very complex because it's a lot of unstructured data, a lot of experience of our expert team. And we're looking forward what's this journey can bring. I hope I gave you an interesting overview of things we're working on, things which worked well, and things which didn't work well, what we learned from that. Thank you for the opportunity to share this with you.
Thank you very much, Matthias, for the deep dive in your experience and use cases. So let's summarize the last, I would say, 20 minutes. I would say first, be agile. Get an early feedback and create a minimum viable product, as you did. Next, define your goals and KPIs. Know precisely what you want to achieve when using artificial intelligence. Furthermore, use the right algorithm, use at the right time with the right data. Next, find one use case to learn and fail fast in order to minimize your risks. And finally, and this is the most important thing, is just do it. So I would like to give you one more message on the way. Don't be afraid to fail. Failure is what all great successes are based on. And thank you for having us.
Thank you.
Thank you so much, Patrick and Matthias. And there's quite a lot of things going on in our Q&A session, so I suggest we move right over to the questions. And let's see what we have here. Okay. In German, so you mentioned 1 and 0-shot learning in the same sentence. How are these two connected? And this is liked by 6 people, so we have a lot of engineers in the room, it seems. So this question is directed to
Patrick.
Patrick, yes.
Yeah, I guess. 1 and 0-shot learning approaches. What we see, we have a lot of pre-trained models in the market, and we can use it. We have a natural language understanding model in our platform, and this is pre-trained, and we can use it, and then we're using the transfer learning approach. So the point is that we have a lot of good models on the market, as Matthias mentioned, that we can use it. So it's not necessary anymore that we're starting from the beginning. So this is the point, that we have good models on the market, and and we can use it. So let's start with that. Sometimes I know it's necessary that we have to start from the beginning in a research perspective, but that's what we see at the moment from I would say in a business process automation, hyper automation perspective. There are a lot of models in the market that we can use, and this is something what we call applied AI. Take it, use it, and hopefully that we be successful.
Excellent. Then for the second question, that is from Herbert. He's asking, 30 days sounds very fast for an hyper MVP. Normally POCs, this means proof of concepts, take that long or even longer. So how is that possible? Please could you elaborate?
Yeah. So how is this possible? He's right. Normally it takes a little bit longer. But the point is, it's something special, I think, for us. The one point is we're coming from the agile world, so we do a really good scoping. And the other point is, when we're doing our project, we have AI operating system in this case. So we're using our platform. We have pre-trained models in it. We have an internal marketplace, and we're using our workflow engine to put these models together. So it's more configuration. And the other point is you have to scope it. I know in these 30 days it's not possible to go in the whole infrastructure of a pharma company or in other stuff, but it's possible to make a small hyper MVP to evaluate if this works, and then you can go further, and then it takes I would say 3 months or 8 until 12 weeks to have the whole solution implemented.
All right, and a lot of questions actually directed to left shift 1. That's for the next one. Actually, you talked a lot about how to set up a use case and what's the business model of left shift 1. Could you provide us any hints on pricing?
Okay. The business model of left shift 1 is for our platform is a typical license model. It depends how big the use case is. So we're selling our skills and we're selling a basic fee. It's something that we can discuss in detail in a private meeting. We are a typical platform, and our partners, they are a lot of, I would say, consulting and system integration companies. They're doing the service, they're doing the configuring. But from our platform, what we're doing, we educate our customers and enable them that they can use AI in an easy way, because we know not every company can work with 10 or 15 data scientists. It's not possible. We don't have enough on the market. So what we're doing is bringing on another layer and using platforms, and our customers can configure the small use cases by themselves.
All right, thank you very much. This answers the question.
Then we have 2 questions directed to the Post, Matthias.
Yes.
Number 1, does Austrian Post also run projects outside of Austria?
Right now, we're pretty much focused on Austria because in our IT department, we set up a so-called Future Lab a couple of years ago. Like Patrick said, it's really hard to get those talents and people. And honestly, Austrian Post is not associated with AI and artificial intelligence algorithms and so on and so on. So we have a challenge on this side. But we have a small team to deal with these topics, and therefore it's mainly focused on Austria. But I have to say, generally in logistics and in the last mile delivery, and if it comes to route planning and delivery prediction, this is something we do in most of our countries where we have engagements, like in Central and Eastern Europe.
Okay, thank you. And one final question before we say goodbye, because you have to leave in 2 minutes. How many AI use cases do you have running in parallel at the moment?
That's a good question. We're trying to make also small steps one after another, because, like I said in the beginning, our team is not too big, and we're not doing only AI in this team. But I would say it's 3 to 5 use cases at one time. Yeah.
Okay. Great. Then here we have at least to cut off the Q&A part with you, Matthias. Thanks for joining.
And thank you very much.
I hope you're later also available on the networking platform for meetings.
For sure.
And thank you for having me. Some of your colleagues definitely are. So.
Sorry?
Some of your colleagues definitely are. There are many people registered. Thank you very much. And have a good day. Bye-bye.
Bye. Thank you.
All right. And I have the special honor to ask the next question. Good. We received some upvotes. Well, this is a question for Matthias, I guess. How is the Post using AI to optimize resource use, for example, fuel power consumption for their fleet? Well,
sorry, I don't have an idea.
Maybe Bernhard tried to get in touch with the people of Austrian Post in the B2B meetings, and they can answer the question, I hope. And also, I can ask that. Great presentation, Patrick, with very valid points.
Thank you.
Thank you very much. Thank you very much.
Good.
Perfect. So we're exactly on time.
Yes.
So it's a premiere for us.
And we have a delay, actually. So this is something that, we receive the questions in real time, but they don't see us in real time. It's 1 minute, 2 minute delay. So just if you're wondering, yeah.
Perfect. Thanks a lot, Patrick. And I hope you and your colleagues from Left Shift 1 are still available for the networking, for the B2B sessions. Also, if you have any further reading material you would like to post, like for example, yesterday, Charles from Sclable had these blog posts on logistics and AI, feel free to share that in the conference channel on LinkedIn.
Yes.
Okay, I will do it, yeah.
We should create a reading list.
We will, a mandatory reading list.
Mandatory reading for the next conference.
Okay, then greetings from Graz to Vienna. Bye.
Thank you. Bye-bye.
Thank you so much. Bye-bye. Well, and also the team of Left Shift 1 is remaining in the B2B meetings where you can talk to them. What's up for us next? We have a little break now, after which
the Eva Eggerling and Martin Riester from Fraunhofer Austria will present on applied AI research in the field of logistics and supply chain management. So yeah, almost 10 minutes, 9 minutes. We start at 10:20 sharp.
This is in 9 minutes. So see you a little bit later, get a coffee, stay tuned. Hello and welcome back.
Hello. This morning. Hello, Eva. Hi, Martin.
Morning.
We have now here with us Eva Eckeling and Martin Riester from Fraunhofer, Austria. Warm welcome to you both. And your presentation today titled Solutions Aiming at Logistics. And Dennis.
Yeah, I mean, without further ado, I would directly give the stage to you. Afterwards, we will take questions as usual from Slido. And yeah, looking forward to what you're going to show us.
Just checking your, and Eva is head of business unit Visual Computing and Innovation Center, KI for Life. And Martin, head of business unit Logistics and Supply Chain Management. So this is interesting. You find them also on the B2B meeting site. And here we have your slides and the stage is yours. Talk to you in a bit.
Okay, thank you very much and good morning, or yeah, it's almost lunchtime, but I think I can say good morning to everybody. I will start, and after 10 minutes I will hand over to Martin, so we have a team talk today. So maybe you can switch to the next slides, because you have the control, Martin. Okay. So we are both from Fraunhofer, Austria, and Fraunhofer, Austria is part of the big Fraunhofer family. So this is what we can benefit from, and probably most of you know that Fraunhofer Gesellschaft is a very big research organization and performing applied research. But to give you a few key facts, at the moment we have about 74 institutes and research facilities all over in Germany and also in some other foreign countries. 28,000 employees and still growing. And we are very proud that in Austria we are part of the family. And on the next slide, you see the worldwide Fraunhofer network. And it's not for, I mean, to make us proud, but it's also like a service for you. So whenever you need partners or a network in other countries, feel free to contact us, because we have the network and you can benefit from the network too. So take this as an offer. But today we don't want to talk about the worldwide Fraunhofer network. It's about the Austrian subsidiary. And we are very proud that we were the first subsidiary of the Fraunhofer Gesellschaft that was founded, it's now 12 years ago, in almost 13, in 2008. 1st of April, not a good date. But yeah, we have grown a lot. We are also about 80 persons now, researchers doing applied research, 6 million euros. And you see the share between research and industry that we, following the Fraunhofer model, that we generate. And yeah, I wanted to mention our two directors, Professor Fellner and Professor Steen, who are the heads of Fraunhofer Austria of all the locations. So in 12 years, we have grown, and starting from Vienna and Graz, where the first two business units were founded, it's now 4 business units and 2 innovation centers. And so today, it's my and Martin's pleasure to talk about the artificial intelligence solutions that are developed at Fraunhofer Austria, and especially for logistics. And yeah, this leads us to the 2 business units that we are heading. So we combine our brains and our power in order to generate as much synergy as possible in this research domain. And yeah, in general, Fraunhofer builds a bridge between the basic research at the universities, so on the academia on one side, and the demands and challenges that have the industry and economies. So on one hand, we listen to the universities. You have 4 of our partners universities listed on the left side. And we talk to them, we get an idea about the latest innovative idea, the publications. But as you might know, an innovative paper is not always directly usable for companies or for industries. So it needs some more work on the new results, such that they can be applied. And on the other hand, we listen to the companies, so we learn about their challenges and the problems that they need to solve. So this is the research task of Fraunhofer, and this is also that makes us special, connecting these two worlds. And here's some of the companies that shows that we are cooperating with. So I think we have a good idea in several branches what are the challenges, and we also give the open questions that come up from the discussions with the companies to the academic institutions, so that they might look for new and innovative research in these areas. So now, the next slide, please, Martin. Let's come back to the logistics topic and the topic of today's talk: applied artificial intelligence for logistics at Fraunhofer, Austria. So we focus on our two units. One is KI for Life, the latest, the youngest location of the 4 locations. It's an innovation center for digitalization and artificial intelligence, and it's focused on applied AI and the basic research and R&D in various applications. And we combine our knowledge with the logistics unit, with Martin's unit, logistics and supply chain management. So we combine the knowledge about the methods with the domain knowledge of the logistics, and we think that this is a very fruitful combination. So let me tell you a few sentences about KI for Life and then about Martin's unit, and then we jump right away into the examples. So on the next slide, you see that the KI for Life is organized in 3 main research columns, let me call it. So the first column on the left, it's the typical research and development column, where we work very strong together with the academic world. The middle part is the economic basis. So we do the contract research with the companies, like in all the other Fraunhofer institutions. But on the right side, the third column is a little bit special for KI for Life. It's located in Carinthia in Austria, and this area has a lot of small and medium-sized companies. So they're not only the big industries. So that's why when founding the center, the special focus was to support especially the smaller and medium-sized companies. And that's what we do since October 2019. So that's the organizational structure. And on the research, the research focus is it's a big field. So it's not that we just do the high artificial intelligence algorithms and just working on the neural networks. It starts with digitization, because especially small and medium-sized companies don't want to solve the big problems with neural network. They have some very basic problems sometimes, and also for them, we want to be a good partner. So that's why we have this picture here from digitization and artificial intelligence, and depending on the problem, it's more on the left or more on the right side. And what we do is that we combine with our researchers the knowledge in mathematics, computer science, computer graphics that we already developed in the last 12 years with this, and we channel this knowledge towards applied artificial intelligence methods. And we organize these research activities in 3 main strategic areas. We organize it according to the data source. So what we're doing is we do applied research on text, on images, and on time series. So if you want to keep something in mind what we're doing, these are the 3 areas. And I want to emphasize that in all our projects, we emphasize the combination of the expert knowledge and the data-driven knowledge. So it's always very important for us to keep the human in the loop and to include the expert into the problem solving. And this leads me to Martin's unit. I want to explain a little bit what he's doing. Probably he could do it better, but we decided that we don't switch too many times. So Martin, please be nice when I present your group. So we take a look at the second unit of Fraunhofer that is involved in today's topic, the business unit that concentrates on the application field logistics and supply chain management. Martin organizes his activities there in these 8 areas. And of course, he keeps the AI topics in mind and applies the methods to the logistics domain. So that's why artificial intelligence and machine learning is the first research square on this slide here. But his group is active in a number of innovation topics, like, can you go one back, please? Sorry, I was, yeah. to like the crowdsourcing logistics that I want to point on, or the physical internet, or autonomous systems and logistics. You see the others listed here. But furthermore, his researchers are also focused on hot topics like the green logistics and resilient supply chains. And this is very important because we can't ignore that resilience and environmental compatibility and resource-efficient logistics is a process that is absolutely essential nowadays, and if you want to keep and preserve the environment. And now you can go to the next slide. And keeping these fields in mind, I want to emphasize the range of service that he's offering. And I don't want to read everything here, but it's really amazing, and it's a big pile. So he offers services starting from the network planning to the spare part logistics and after sales. And one of the examples that he will show later on is especially from this field. So in short, we can name this range of service like research, planning, optimization, and implementation in these various fields. So now you'll learn a little bit about our 2 units, but the magic is the synergy. The synergy effects at Fraunhofer Austria is about combining the knowledge. So we have the Innovation Center specialized on the applied AI, and we apply our knowledge to various application fields. So, for example, we have the resilience forest, or topics like fishery, the building information modeling area, or health and pharmacy, and also air traffic control, and the logistic. So we are the method and technology part spreads to the application field. And if you can combine it with another unit focusing on a special domain, this is my main point. So the synergy effect is what makes us strong, and especially the interdisciplinary teams that work together here. And that's what we are aiming for, and that's why we are here today, especially aiming for solutions in logistics. And therefore, we have prepared 2 concrete examples for you that you see on the next slide. And so one is from a very intuitive example from the commercial vehicle industry. I think it's the second example, and the first one from the commercial sector. And I think that's the perfect time to give the floor to my colleague Martin, and he takes over from the logistics and supply chain management point of view.
Thank you, Eva. Welcome from my side. I prepared 2 use cases today for you. As Eva has already said, one is located in the commercial sector, and it's dealing with crowdsourcing delivery, and the second one is out of the commercial vehicle industry, and this use case is dealing with spare parts demand forecasting. Let's start with the first one. The first one is a public funded research project we started last year. It's called Stand PI, and the objective is to optimize the package distribution, especially in the last mile. So basically, what was the initial situation we were facing before we initiated the project? So basically, there is an increasing shipping volume during the last years due to different reasons. One is for sure the increasing amount of online shops during the last years, and the whole development was definitely pushed by Corona in 2020. On the right-hand side, you can see in 2014, we had in Austria 151 million shipped packages. In 2020, already 287 million shipped packages. This is an increasement of approximately 90% just in 6 years. and you can transfer it to other countries in Europe. There is a similar development. And the other issue we were facing was there is an increasing amount of road transports. It's expected, if you measure it in ton kilometers, that there will be an increasement of about 30% from the years 2010, 2020, 25. And at the same time, there is a huge number of private cars on our roads which are not used for transport purposes. We are driving every day to work and back, and we don't transport anything in our trunks. And just to give you an imagination, an example, I prepared a small example from the Tangente in Vienna. It's one of the main roads here in Vienna. And on this road, we have on a daily basis approximately 160,000 cars. And if you sum up their trunk volume, it's about 41,000 cubic meters per day, which are not used for transport. And just to express it in semi-trailers, this would be equal to 430 semi-trailers per day. And in a year, it would be, I think, 57,000 semi-trailers per year, which are driving on our roads in form of cars, which are not used for transport. If you would put all the semi-trailers in line, just to get an imagination, it would be in a distance from Vienna to Paris and back. So, in other words, there's a huge potential how to use these private cars for the transports of goods, or parcels and packages in the B2B business. And the question was, how can we use these cars which are already on road for commercial purposes? And the current challenge is that there is in companies separated optimization, or in many companies a separated optimization of the provision of goods. So means the intralogistics and the optimization of the distribution. Accordingly to your internal planning, you define a number of transport volume you need. And if you need more transport volume, for example, that you have more orders in your online shop, it's very hard to change these plannings in case of peaks. And the second issue we are facing is the integration of crowd itself. At the moment, there is no possibilities for companies to integrate a crowd or crowd members in their B2B processes. And the reason is mainly there is no technical solution for it. There's no platform or anything. A second reason is the planning capability. You have uncertainties if you integrate crowd in your processes. You don't know if there is a transport capacity, yes or no. And you have several uncertainties from an organizational and legal perspective. And based on this situation, we initiated our project. And what are our objectives? In this research project, we want to do some research. We want to create a link between the shipper and the private transport capacities, basically between the crowd members and the companies. And then this requires a lot of research in different dimensions. First of all, we need a technical possibility to integrate the crowd members. And we also need reliable controlling mechanisms to interlink the intralogistics and the transport capacities. And this complexity requires the use of AI. Some details will follow on the next slides. For these ambitious goals, we gained some ambitious partners. With us, as I already said, is the Austrian Research Promotion Agency, FFG. And beside Fraunhofer, we have also the Technical University of Vienna with the Faculty of Informatics on board. We have Jack Robin on our side, which offers the expertise regarding crowdsourcing. We have Schrack Technik in our project. They are a retailer for electronic components. We have Johann Weiss. This is basically a transport service provider. We have the Aspern Mobile Lab with on board. This is our interlink to potential crowd members. And we have also Spar with us, which is one of the biggest food retailer in Austria. And the question is, how can we, what is our approach? How can we interlink all the stakeholders, and especially how can we combine the two perspectives, shipment and traffic? And the first thing we're going to do right at the moment is we need to design an interface first based on static factors. static factors from a transport perspective and static factors from a intralogistics perspective. That means basically, for example, the destination. So you want to ship a package to a certain destination. I need to know where the capacity is going, and so I need to know the route. I am, for example, also on arrival date and arrival time. You have expected arrival date and arrival time, and also the capacity means basically the dimensions of a package. How big is the package? Does it fit to my capacity? So these are static factors. But we also have to consider further dynamic input factors, which might differ over time, and they can positively or negatively impact our whole system. On a transport logistics side, for example, on the intralogistics side, for example, is the current system load. It's about it's also the resources, means what is my staff, is anyone ill, and also obviously order status. Is the shipment already ready for dispatching? Is it ready for pickup, or is it still somewhere else in the process? And on the transport side, you also need some system parameters which could be dynamic. For example, the weather. On rainy days, there might be less traffic than on sunny days. In the morning, due to the rush hour, there's maybe more traffic than in the afternoon, and so on. And this complexity can't be solved by humans or by normal logic. And for these reasons, we want to apply different machine learning algorithms first to forecast a provisioning date on the company side due to different impact factors, and second to forecast a defined pickup time. So when will the transport capacity available for our transport? And combining the static factors and the dynamic factors. So we use at the moment the colleagues they think about, or they're working on a comparison of the collected data. So during the last half year, they collected the data, and now they're trying to apply different algorithms to recognize relevant patterns for the forecasting. And in the final state, we plan the matching between the transport capacity and the package itself. And what are the expected results out of this project? First of all, we want to develop a mechanism which enables basically the matching of the transport capacity and the transport demand. Second, we want to develop a demonstrator, a proof of concept demonstrator, just to validate if the whole system is possible and what's the impact, what could be the impact of such a system. And third, also a very important part is a requirements catalog with stakeholder-specific requirements. Especially, we want to use it to derive political recommendations, because we already know, for example, between Germany and Austria, there are differences for crowd members, what is allowed as a crowd member, what is not allowed as a crowd member in the perspective of transporting goods. And the benefits at the end, what we want to achieve is, first of all, we want to contribute to the reduction of CO2 emissions, and we want to reduce additional traffic, since we use the vehicles which are already on road. And second, we want to offer the companies a possibility to increase their service level and to optimize their transport costs. Just imagine if your cut-off time in the evening is maybe 6 p.m., but there are still crowd members who could transport your goods after 6 p.m. Your customer will get your package at the same day, maybe at 10 p.m. And this is definitely a benefit, especially in urban areas. And the third one, what we want to achieve is we want to offer crowd members the possibility on an additional income, and basically for all of us the possibility to contribute to sustainability. So basically this was our first project we're currently working on, and now I will go into the second example I brought with me. Is out of the commercial vehicle industry, and it's about spare parts demand forecasting. And this project is more practical. It's a project with one of our industrial clients, and he asked us to optimize his spare parts business. And we did this project together with the company Lindner. Lindner is a manufacturer of tractors and transporters. The company is located in Tyrol, Austria, and produces agricultural vehicles for different uses. For example, grassland management, mountain farming, viticulture, and municipal use. And what was the situation when we came there? The company was facing in general an increasement of their turnover, the spare parts turnover during the last few years. So obviously everything was okay. But when we had a closer look into the data together with the company, we have seen that this was not the case for all customers, especially for some major accounts. Some major accounts had a declining turnover during the last years, and this was due to several reasons. Specific items were obtained by the customers from third-party providers. The parts availability in general did not meet the customer expectations, and also not the internal expectations of Lindner. And the material planning process itself was quite challenging for the staff, because some planning tasks were performed on a very manually basis. And a further aspect was that they had a limited support by their planning system. First, they didn't use the functionalities of their system to a full extent. And second, some of the functionalities, especially some of the algorithms in their forecasting algorithms, were not suitable to predict all demands of the spare parts. And on the supply side, they also had the challenge that that suppliers couldn't realize express deliveries, and that led to the factor that they had to keep all the items in stock on their own. They couldn't realize direct shipments, and the replenishment times were in some cases too long, and that also was a reason why they had to increase their inventory stock levels during the last years. And there's in spare parts level and in spare parts management in the agricultural area, there's an additional factor, and these are seasonal fluctuations, because normally all the farmers repair their vehicles before or after the harvest time, so that they have a full availability during the harvest. And during the harvest time itself, normally the spare part sales is limited to emergency parts. And additionally, the demand is impacted by external factors, like, for example, the weather. If there is a good weather, they enlarge their harvest time. If there's a bad weather, you have a shorter harvest time. That means a more intensive vehicle use and increasing demand of spare parts. So what were the derived tasks for us? First of all, we had to analyze the whole planning process itself. I don't go into in more detail within this presentation because it had nothing to do with AI. Second, we had to analyze the range of the spare parts itself and some data analysis that performed the data analysis from a materials planning perspective. And third, we had to derive optimization potential, not in general, but on an item number level. And on the next slide, I give you a short overview of the work of my colleagues. Just to give you some facts and figures, in total, they analyzed more than 40,000 article numbers within the master data. We had about 18,000 storage locations within the company, and the whole stock, inventory stock, the value was about 3.7 million euros. Just that you have a short imagination. And my colleagues, they analyzed the transaction data of the last 3 years, which means approximately 400,000 single transactions. And they conducted the analysis in several steps. First of all, they focused on the identification of relevant data sources. Then second, when they collected the data and evaluated the data with specific rules, They created failure reports, automatic failure reports, which they discussed afterwards with experts from the company. And based on this processed validated data, they proceeded different analyses. First, they did some basic analysis with our inventory track, and this is the tool, this snapshot you can see of our tool. This is basically for basic analysis. So we can visualize the consumption pattern of each item on an item level. We can classify the article with standard analysis like ABC, XYZ. I'm sure many of you know them. And we also can create important metrics like average consumption per period and also dead stock analysis, for example. And the big advantage is that the experts of our customers can analyze the data on their own and validate the data on their own. So if there are some failures, you recognize them very fast. And based on this analysis, especially on the consumption pattern, they applied different forecasting algorithms on the different items, and basically they assigned the possible and the best fitting forecasting algorithm to each item based on this was the basis for deriving the dispatching parameters later on. And the fourth analysis they made is, and now it's a little more into the field of AI, they analyzed the data with association rule mining. And the objective was to create spare part bundles, and especially to mitigate the issue I mentioned in the beginning, that some customers order their spare parts from a third party. And what was the result? The result at the end was that they classified the range of spare parts into 3 classes. First, it was in items which were no sales items at all. Second, sales items means sales items which are included in currently produced vehicles or created after the year 2016. And the third class, which was the relevant for us, were sales items which were not included in currently produced vehicles and which were integrated in the system before 2017. In total, they identified 39,000 items. And this was especially interesting because in the system, 24,000 items were marked as spare parts. But based on our rules and our data analysis, we identified that they have basically 39,000 spare parts, or at least items which should be treated as spare parts from a sales perspective. And second, based on the forecasting algorithms, the colleagues parameterized the standard order point procedure for 11,700 items. So basically, they derived the parameters for all these items. They provided it in a system upload, which was later on uploaded in the system. And this basically increased the semi-automatic order handling to a very high degree. And based also on our analysis, they identified some phase-out items. Lindner provides or guarantees its customers 30 years of spare part supply. And to identify all the items which are not necessary anymore to be supplied by the company, they made a breakdown of all bill of materials from all models which were produced within the last 30 years. It was quite a big amount of data. And as a result, they identified 2,915 phase-out items, which were transferred in a sales promotion action. You can see it on the right-hand side. It was a summer sale promotion, so that they can earn some money out of the phase-out items which are not needed anymore. And afterwards, the rest they were scraped. And in the last result was that they anticipated the customer behavior. So basically, with the association rule mining, they analyzed their 100 biggest customers. They identified the difference in the order behavior. They made classes with comparable customers. Then they defined the spare parts packages based on a sales perspective, but also on a technical perspective, means which spare parts do you need with each other. And at the end, now they can create recommendations, shopping cart recommendations in their online shop. And basically Lindner now suggests their retailers what to keep in stock, means which item and which stock level. And as a last sentence, then we'll finish, is that just to give you an outlook, the association Wool Mining won't stick to the creation of spare parts packages. They also enhance it to their vehicle configurations to optimize the vehicle configuration in regards to customer needs. I hope I could give you some interesting insights to ongoing projects, and looking forward to your questions. Thank you.
Yeah. And we're back again. Thank you very much for the presentation. This was very insightful, because you, on the one hand side, you explained how Fraunhofer is structured and your group, and then the deep dive into use cases. Since we are running a little bit out of time, I would switch directly to the Q&A session, because we received a number of questions.
Yeah, let's have a look. Let me pull them up. All right, maybe we can go through them from top to bottom, and you can still vote and ask questions if you're quick.
Okay. Now let me pick up the first one. How do you see the competitive situation between contract research, government-funded startups, and private service providers? Coexistence or co-opetition? I think this is the most possible Austrian question I had ever encountered.
Maybe I start answering this. Yeah, definitely. There's a third possibility, so I would call it cooperation. So it's not only coexistence, and definitely not competition. We are not here to compete. We are here to cooperate and not to steal contracts from small companies or startups. So I think we can contribute with our innovative ideas, and yeah, definitely we are on the cooperation side.
Yeah, maybe I can add a comment. We also include startups in our research projects. This is that there's a close cooperation.
All right, and we have received a few upvotes for the next question, a little bit longer one. Regarding the crowdsourcing delivery, have you considered the legal requirements? Alexander.
Yes, yeah, we have it's planned. It's part of the stakeholder analysis, also the legal requirements, and there are also some restrictions. And for example, we have, like I mentioned it during the presentation, we have different restrictions in Germany. In Germany, for example, it's easier to act as a crowd member than in Austria, especially in the transport, in the field of transport. And but this is one of the outcomes, one of expected outcomes. We want to make a list with the restrictions which may limit the possibility to set up such a system. And like on the last slide, I mentioned that we want to give some recommendations, political recommendations, what need to be changed. Yeah, I think we had this in the past. We had this in the field of taxi and person transport, and yeah, and we plan to make a list. What are the limiting restrictions at the moment? Yeah, we have it in our focus. Yes.
All right. So this answers that question, and for the next one.
Yeah, then I think the next one is picking up on the previous talk where Post and Left Shift 1 were talking, because it says in the previous talk we heard of proof of concepts and minimum viable products. Is Fraunhofer supporting the entire life cycle of an AI project from POC to production system, or do you do a handover at certain steps? I guess this means either to the internal team or to one of the big service providers out there.
Yeah, maybe I start answering this. Yeah, we definitely can provide the whole cycle, but very often we don't do. So it depends on the project and on the problem. So we can start from the first study over POC, and then also integration into a system of a company. But if it makes sense, we try to include the internal group, the IT, to get them started and to at least be included in the integration. because if we do it, sometimes it doesn't make sense if they have to call us every time something happens. But if there's no IT or no group who can take over, then we can provide the whole system. And very often after the POC and that after the innovation approach is successful, then we are looking for a small startup or software company that can hand over the service. So we don't want to do the 24/7 thing for all our customers.
Right. Thank you so much, Eva. Thank you, Martin of Fraunhofer. You will stay around for the meetings, and
yes,
we reached the end of our time slot and have to go right over to our next speaker. Thank you so much. And
thank you, guys.
Thank you.
Bye-bye.
Bye.
So, and for our next speaker, let's see if we have a connection.
Yes. Hello. Can you hear us, Franciscus?
Yes, I can hear you. Can you hear me and see me?
Loud
Yes,
and clear.
loud and clearly.
Crystal clear.
So,
Great.
Yeah, short introduction. Yeah, this is basically the first surprise guest of the day because we didn't have 7lytics in the program yesterday. The reason is, let's say, something fell through the roost. But we're happy that on short notice you could join today. I mean, a little bit background for the audience today. Franciscus and his startup 7lytics are among one of the very first AI startups in Austria. So very, very early. I talk way before the current AI boom. Plus, especially in the field of demand forecasting, which is also the topic of your speech today, you're like pioneers coming from retail, from industry, and so on. But yeah, I don't want to spoil too much of the contents.
And let's see if we have your presentation ready. And here we go.
Yes.
Talk to you in a bit.
Thank you very much. Thank you very much for having us on a short notice. I'm very happy to being able to present today. Thanks also for the kind introduction. As Clemens said, we are doing AI since 2012 actually, and in the form of 7lytics since 2016. And demand forecasting is one of our most hottest use cases what we do. So this is what I'm going to talk about today. The goal of logistics is to have autonomy, and this is what we all want. Yeah, we want to achieve autonomous logistics so we can have more spare time and do creative stuff and drink coffee or whatever. Yes. What do we need to do in order to achieve this goal is that we need to turn all ships and planes and trucks and trains into autonomous agents. They need to be full of sensors and IoT and communicate in real time and also optimize in real time and expect unexpected events and change the routes and whatever. Yeah, and this is a very ambitious goal, but in 5, 10, maybe 20 years, it will be at some point become a reality. And on top of the hardware stuff, you also need a software component to this, of course, which you could use some kind of reinforcement learning engine to optimize everything that happens there and have optimal routes or at optimal costs. This is also going to happen. It's happening now. Also, Clemens is and Light AI and AI Austria are heavily involved in this. And of course, this person here, who we all know, Sepp Hochreiter, who lives here in Linz, where we come from, and who is working on a reinforcement learning algorithms which can optimize also events or costs that happen later. Yes. But until we get to this point, there are some hurdles and some problems coming on. And it was quite interesting because one of the participants of this conference who looked at my website wrote me, well, yes, you do AI, but you say also give us your data and we will solve the problem. And the problem is there are no data. Yeah. So and one of the reasons there are no data is, of course, because not every vehicle is connected to the internet yet, and also that we live in Europe. We have one of the best organized transport networks in the world. But still, some core processes are very manual. So if you in the German-speaking cargo area, a Frachtbrief, yes, is a piece of paper, yes, and this is not digital. And of course, now it's getting more and more digitalized, but we are where we are now. And one of the most important things, and this makes companies like us or the methods that we use necessary, is that planning is done manually. Yes, so I know a lot of companies in the German-speaking area where the planning looks like this. Once a year or 2 to 3 times a year, people come together and give up a forecast for the next 12 to 18 months, and this is brought together in Excel, and this is how things work. Yes, and another problem is that it's not always very clear what is going to be optimized. Are you optimizing traveling costs? Are you optimizing time? Or do you want to optimize customer satisfaction? Yeah, this is not per se clear and it's not formulated. So we have a lot of problems. And what we recommend is trying an agile analytics approach. What does this mean? Before we go to the one monolithic big AI system which is going to solve every problem, start by splitting the problem into smaller sub-problems which you can actually solve now or try to attack now, and pick a use case that you can handle and that doesn't need 3 years of preparation, yes, but brings you some kind of benefit, and then start doing it. Actually move fast and get it on. Yeah, this is a good strategy. So the one use case that we are going to talk now is demand forecasting. I remember a CEO of a big retailer in Austria, who is now a CEO of a big retailer in Germany, said to me once, this is the holy grail of retail, but also of logistics and of manufacturing. Because if you know how much of each product you're going to need at every point of sale or point of contact, yes, then you can, the rest is details, as Albert Einstein would say. Yeah. So what you need to do is you need to start asking some questions to get it. How do you plan now? Yes. Do you plan based on business experience? Do you plan based on intuition or random? Do you use your ERP system with some hard-coded safety stock rules? And the question that people often don't ask is, how accurate is the planning, the current one? Yes. And of course, also in times of crisis or shocks or COVID, you need to ask, well, what made up our biggest misses? This is not only for Corona time, but it's general. Yeah, you need to, when all models are wrong, but some are lethal, and you need to somehow find out where the biggest errors are. Yeah. So if you have to ask these questions, then you can actually start setting up a pipeline. And the pipeline is actually it's a standard data science analytics approach. Yeah, this is nothing particular. You start with your own data or the company data, then you augment that with external data, and there is a lot of that which you put in some scalable architecture like a data lake, and then of course you need to clean all of that and visualize it and explore it and find out what's happening there, and then you start making some predictions. Sometimes you also go and make prescriptive analytics like recommendations, and then you monitor your system and integrate it with what you have. Yeah, this is how things work out. This is a process of data science. And of course, you should use interactive data visualization the whole time to see what's happening, because nobody likes a black box. And nowadays there is a standard open source stack which you can use, which is very good. It's used by the biggest companies in the world, so there is no need to use proprietary algorithms which are somehow behind something. Yeah, everything can be transparent. And let's start by the first piece and the main problem, the data. So what kind of data should you use for demand forecasting? Well, everything you can get. Yeah, the base is transactional data, orders, stock, sales, movements from A to B. Yeah, then you need to know what kind of products am I transporting? What kind of products am I are being sold? Yes, with everything that belongs to those. What is extremely important is marketing. We have seen cases where marketing actions make 80% of sales in a year. Yeah, and this is in some single days. So you need to know that in advance and incorporate it into the system, else every system is going to fail. Everything you can know about the customer and allowed to be know about the customer, and here let me stress that we don't mean privacy invading information or personal data, but we mean usage data or features that you can share safely. Geographical data, competitors, socio-demographics, and of course, this is very important, time. Calendar data or events. We have seen in supply chain networks that a train can stand still in Germany, for example, if there are school vacations, because nobody is there to drive it because they've taken holiday, stuff like that, quite important. And of course, last but not least, COVID-19, it's not about the actual numbers that we have today in Upper Austria or in some other country. It's about how can a lockdown affect your sector. Yeah, if you're in fashion retail, a lockdown or gastronomy, it can affect you highly. But some other sectors actually make more volume during COVID in the last year. Yeah, so this all has to be taken into account. Another important thing that you need to know is that demand forecasting is hierarchical. So you don't make demand forecast at one level. You can do it across several dimensions, yes, like SKU, product group, department, across time. You can make it hourly, even in real time for the next 30 minutes or something, but daily, weekly, monthly, yearly for several years. And of course, depends on a market, a country, region, cluster, point of sale, and of course customer. Yeah, these are all different dimensions, and in practice what we do is we play through different scenarios, and it's quite important that the numbers stand up. Yeah, so if you make a low level forecast for the next 28 days daily, and then you make a high level forecast for 12 months monthly, the numbers of the first month need to coincidence with each other, and this is not always the case. You need to have special methods which solve this problem for you. And what's also important is that different configurations of demand forecasting also address different people. Yeah, so a short-term product level per point of sale, so per SKU for the next days, is about out of stock. It's about replenishment. It's about store management, and in logistics, it's of course about short-term production planning. Yeah, so how much resources do you need? Yeah, and we're talking here about days to weeks. A mid scenario is when you do the next couple of months, let's say 3 months, and you want to optimize your networks across different markets. Then this also involves logistics, and it involves moving also products from A to B across different supply chain and point of sale points, and here you operate also a little bit at a higher product level. So you will not have every SKU, but maybe you work at the product group. And then of course, there is long-term forecasting where you operate on a setting of, 20 to 24 months. And this is for strategic planning, long-term planning, controlling, financial controlling also, and C-level executives want to know about that. And you need to allocate your resources in time. Yes. Now, why don't just use simple models for that? Well, because they fail. You can see examples of moving averages, naive forecasting, Croston, whatever. You can use them, of course, but the accuracy is bad. Yeah, so that's why you should use AI models and machine learning models and try everything out that you can. And you can see here in this example, this is from Walmart data, where you start by an error of 13% with a simple model, and you move up with an ensemble of machine learning models to an error of only 2%, and the correlation between predicted and actual value is quite high. Yeah, so you get to the famous 95%. An additional complexity is when you, of course, optimize a supply chain network, because here you don't only have isolated point of sale and SKU, but you have a whole network. Yeah, and we did this for Deutsche Bahn, for example, across 150,000 relations, and we could show that we minimized the error over a long period of 6 times. Here also technology comes in with graph neural networks, but this would take me a little bit more time to explain in detail. What I would like to show you in the last minutes would be that you should use network effects. Look which products are being sold or transported together. This can give great insights. You should use event of calendar and, of course, pricing effects. They have an influence, but it's not the typical influence that we expect from smooth curves of economical theory. Yes, it's always non-linear and partially stochastic, and you need to think about how do you deal with new products, because this is what your actual time series look like. Yeah, something is sold or transported for years, another good can start now, and you need to deal that in the demand forecasting. And after the fact, after you have trained, you can go on and extract some insight about the influences. So you can see what was the influence of the weather, the calendar, marketing, sales, and so on. And the highest art or the most hard thing to do is to predict the market for new products. Yeah, because here you have no history at all. There is no time series. You need to work, for example, in fashion with images or product attributes, and you need to train. Here AI is a big help, because you can use convolutional neural networks to train image data and see how the market entry will be. Yeah, social media is a factor. You can predict fashion trends. This is all stuff that you can do. And after you have mastered now demand forecasting and use it, you should also take a look at stuff that can happen on the road while you're transporting, like predictive maintenance. I mean, if you use trucks can fail, trains can fail, planes don't fail so often, but they can fail also. And here you can use other AI methods like predictive maintenance to get sure that you actually fulfill your own forecast. And last but not least, and then I'm done, it's all about the customer. The whole logistics is about fulfilling customer needs. And don't forget that you can also not only predict what the customers can do, you can also influence it by, for example, recommending personalized product offers and stuff like that. Yeah. That was it from myself. I'm Franciscus from Sevenlytics. We are from Linz, Austria. 20 people have gotten €2 million investment, and our happy customers are partially also investors of us, and we try to please them by using solutions like demand forecasting. Thank you very much.
Thank you so much, Franciscus, for this presentation. And you can still ask questions in Slido, and we have already received a few. Let's just quickly pull them up. All right, so Clemens.
Let's start with the first one. It's a technical question. Which features would you rank as top dependencies in fast-moving consumer goods retail?
Yeah, for short term, we have seen that the weather has a very high influence of sales. The problem is you can only have a safe weather forecast for up to 3 days. So for long-term planning, it doesn't work. It has for most product groups, it's very important. Second comes marketing, yes, and then there are, well, depending also, it's a little bit different on the sector. Yeah, it's like this. We are not consultants who come to you and say, this is how things work a priori. You need to put in the data, train your model, get a good model out, and then you can answer these questions in detail. But this is straightforward.
All right, thank you very much. And a question has been upvoted. Yesterday, one of the corporate speakers mentioned that they see demand forecasting as an internal competence due to its high importance. What are, in your experience, the main factors if companies go for an external solution like yours or do it internally?
The main reason why companies come to us is lack of know-how in doing this properly, because we have customers which don't have data scientists, and we have customers which have 30 data scientists, but these people also don't always have the time for everything. And it's actually, you can start immediately with demand forecasting, but if you want to get it real proper, it needs know-how, complexity, and then you go to people who have solved this problem again and again and again over many years in many different sectors, and then you can profit from their know-how. But you can always try to do it on your own. Yeah. So actually, we ask for benchmark models from our customers, and then we show that we can do it better.
Also, data scientist teams don't have to reinvent the wheel. In short, so
the next question is from a speaker from yesterday, from another Clemens. How do you customize to the needs of specific customers, and what are the main challenges there, and how long does it take to customize your size?
Yeah, this is a very good question, and as we try to avoid making on-premise stuff, so when we have a use case like demand forecasting, we abstract it out and make a pipeline which is not customer specific. So we separate code from configuration. Yeah, and we have customers with any kind of ERP, with all kinds of sectors and different needs and so on. So this is just configuration. So this actually gets done. In practice, what takes more time is talking about, looking at the results. The people need to think what they want to do, and so on and so on. So to give you a relatively feeling, in 3 months we have a POC MVP thing through with demand forecasting, including all meetings and stuff like that.
Mm-hmm. Good. The next question is, well, it's following a little bit along these lines. You mentioned that you're in the AI business since 2012. What has changed in terms of customer acceptance and willingness to pay?
Well, we see some changes. In 2012, when we my wife and I founded our first startup, Simplectics, and then we tried to sell recommender systems and demand forecasting, and people said, "What do you want from us?" So it was very hard, really, in Austria. In the USA, not. We had customers from there, but now people have. I have the impression they understand it. You can see based on the job offerings that they're looking for data scientists, and we made the job recommendation engine for Karrierati in 2013 using AI. There was no data scientist then. Yeah, you had no jobs back then, data science or AI. You have it now, and people understand that we need budgets, we need experts. There are companies, not only us, but others who see a market and come, and this is a very positive thing, because as we all know, these tools and use cases will become standard. Whoever does not do it now is falling back. So I see an opening here.
Mm-hmm. Maybe one follow-up question from my side, because about the business model, you mentioned software as a service, you run it in your cloud. What we see in manufacturing at previous events was that many companies, many startups tried to initially offer a software as a service, but they found out that industrial companies want to have the solution on-premise. So they're switching from a monthly subscription model to a rather medium or heavily customized on-premise deployment, basically with an annual enterprise model. How do you see this evolving for demand prediction, or is this something that is already settled and accepted, that it's, let's say, taken from the cloud?
We also have some customers we also have banks as customers. One bank is co-owns 20% of my company, Raiffeisen Landesbank Oberösterreich, and of course, if you have sensible data, nobody gives it like this out. Yes, so we also have some hybrid, but you can. Most of the people for demand forecasting, most companies accept that you can put it into the cloud, and if you guarantee security, then it's fine, and then they can live with a monthly, quarterly, or yearly fee. Yeah, but there are also some special cases always.
Mm-hmm. Perfect.
Yeah, excellent. Last sentence to that. I think it's less about the business. It's more about security and trust here. It's not, but because every software as a service company can offer to be to have a better price than a huge on-premise monolith. Yeah, this is easy economics. It's cheaper. Yeah, but it's about data, trust, security, and stuff like that, and know-how, which people don't want to give out or want to get.
Mm-hmm. Yeah, thank you very much, Franciscus.
Thank you also.
Analytics is also in the B2B meetings, so reach out to them if you're interested in getting to know their service in more detail. Best wishes and talk to you soon. Bye-bye, Franciscus.
Thank you. Goodbye. Have a nice day. Thank you.
Bye.
All right, great. So for the second surprise, or let's say unplanned session of today, we were thinking that besides just posting a banner where we show you what's up next for the AAIC, we make a dedicated session for it. So after the next break, we will spend around 10 minutes to show you what we have planned for this year. And more importantly, we would also like to get your feedback, what you expect from us in the future regarding format, content, and so on. So stay tuned and see you in exactly 5 minutes.
And we're back. Hello.
So hello to the last session of the, let's say the last segment of the morning session of day number 2. And as announced, we would like to provide you a little bit overview of what to expect of the AAIC regarding upcoming events and formats. So yeah, let's start with our plans for 2021. So yeah, here would hand over to Matthias.
Well, we have some initiatives planned for you. As we mentioned, we started to go deeper into special industry sectors starting from last year. As we noticed that our virtual events were accepted very well by people who are concretely interested in use cases in their special industries. What we have planned for this year is a deep dive into fintech, a deep dive into semiconductors and silicon chips, a deep dive into AI in the gaming industry, and of course our main event in May, on the 27th of May 2021.
Yeah, so wait, let me get rid of the logo. Yeah, as far as silicon is concerned, I mean, on the one hand side, it was also mentioned during the keynotes in the last 3 sessions we had, that AI chips are becoming a more and more important topic, both when it comes to performance, because training of more complex AI models is getting cost prohibitive and takes lots of time, but also when it comes to edge deployment. And what we have planned with regard to silicon is in April an event with exact date to be announced. But yeah, if you follow us on LinkedIn, then you will see the announcement anyway. And on the one hand side, we would like to show how is AI used by, let's say, classical silicon and chip companies like, let's say, Infineon, for example. And on the other hand, also show you how startups like AAIC from Austria or Plumerai from the UK, or the real big guys like GraphCore, which is already a unicorn, also UK-based, how they are making dedicated chips and similar designs like ARM in the context of AI. As far as the duration is concerned, this would be at maximum a 1-day event. Could also be that it's 3 to 4 hours. Depends a little bit on how, on the questions we will ask you later on. Next.
Fintech, applied artificial intelligence in fintech. We plan this as a part of the week-long Vienna Up event, and we partner with the Austrian Association for the Banking Industry and Fintech Austria, and of course also our partner also for this conference, the US Commercial Service in Austria.
Yeah, as far as the content here is concerned, we didn't call it finance on purpose, because we really want to focus on fintech and mostly on fintech startups. This goes like from everything, every type of banking app you have on your smartphone, but also when it comes to data anonymization, like companies in like mostly AI, for example, very successfully conduct also in the United States. And perhaps we also make a specialized event on finance that would be longer, not just 2 or 3 hours. And there you would see the likes of, let's say, ING from the Netherlands or JP Morgan from the United States and so on. Nevertheless, we are very happy that, again, for this event, the US Commercial Service will partner with us, and also the Austrian Chamber of Commerce located in New York City, because, yeah, finance and New York is profit.
Our main event will take place on May 27 and May 28, 2021, the Applied AI Conference 2021. And the main topic is State of AI. How did corporations embrace AI? And here we partner with several organizations around the world. A few to mention: Hub IA France, so the AI Association of France, the US Commercial Service, AI Bulgaria, our friends at Network Development Hub, and Springer Professional Publishing House.
Yeah, and as far as the content here is concerned, we want to, for this talk, it's a little bit like, if you look in the rear view mirror, the current AI boom cycle is 6 or 7 years old, depending on how you count. And we want to put corporations on the stage which are representative for the industries / country. This is also explains the International Partner Network. to show how did their AI way look like. Did they build up dedicated teams? Where in the organization are these teams sitting? With which topics are they dealing? Make or buy, but not just in the sense, do you develop something on your own or buy external solution, but also in the direction of mergers and acquisitions. And for this, yeah, we already are in talks with the organizations listed below. For example, you can expect a keynote from OpenAI, and additionally from the head of the Dubai Expo 2021. So yeah, this is like larger organizations. And we're also very happy that as a media partner, again, we have Springer Professional, which means that the keynote speakers will also provide, let's say, long form articles, which can later be read up in a Springer publication.
So all about best practices in applying AI in businesses. Moving on, we plan an event in the second half of 2021, applied AI in the gaming industry. Gaming, of course, a perfect testing ground and breeding ground for new technologies, for simulations, and we are inviting the best companies around the world to share with us their use cases of how they actually use AI in their products.
Yeah, so expect CD Projekt Red from Cyberpunk 2077 fame.
Is this confirmed?
Yes. And yeah, there's also very high activity in Europe in this field. It's just not so visible from the outside because these companies are producing tools for game developers. So they're like tier 1 and tier 2 suppliers in the gaming industry.
Mm-hmm. A lot of lessons to be learned from gaming, also for other sectors. And of course, we have some further ideas.
Yeah, I mean, when it comes to further ideas, finance, I mentioned before, when it comes to the topic of sustainability, public sector, we can also add government technology and the energy sector. We are still in discussion with other partners to get a better idea of the exact framing. But it's these three mentioned here, finance, sustainability, and public sector, are three avenues we are actively pursuing at the moment. If you have any further ideas, and we will come to the questionnaire later, be our guest. What is also very important for us to get as a feedback, I mean, as you might have noticed, the AAIC is switching or changing a little bit each time we're doing this. It would be very interesting for us to know what is the ideal format you would prefer. Is it that we do it like as it is already? This means it's either 1 or 2 day full program. In parallel, you also have sessions for B2B networking. Or would you rather prefer a setup where we have, let's say, between 2 and 4 days, only in the morning session program, and the afternoon is networking, I don't know, playing with your kids, whatever. Because from an organizational point of view and content point of view, it's the same. It's just not so condensed anymore. And we're asking ourselves if perhaps it's easier for people to attend if we roll it out. Yeah, additionally, besides having these special topic events, we're also playing or toying with the idea of having a regular format. So here again, it would be very interesting. Oh, this is, I see the first results coming in. That's a very, very 100% for one option. I will show it to you later.
Yeah, there's 1 minute delay. We pulled up a poll for you on Slido, which you can see here on the right, or you join Slido at slido.com with the event code AAIC log 21. And here we listed the options for you, and we leave that open for a while. Just give us your feedback on what type of event you would see has the best fit for your needs. This is what we would like to know from you. And the options, Clemens already listed some of them. A 2-day to 4-day program with half-day slots and B2B open for the entire week, or a 1 to 2 day full program and B2B meetings in parallel. Or also there's the option to actually run a regular format, like once every 2 weeks or once every month. And do that with just 1 or 2 presentations. So very concise, very focused, and with Q&A. Or even, are you interested in additional low barrier formats like, I don't know, podcasts or clubhouse talks where we can further exchange on use cases of AI?
So it would be really helpful if you could send us your feedback. So, I mean, you're in the poll anyway now, but we will also show you our contact address. And for all people registered on B2Match, we will also send out a questionnaire afterwards, like we always do after the conferences, to get a better idea on future topics, speakers, and so on.
And let's just quickly have a look at the feedbacks that we got. Well, most of you prefer the 2 to 4 day program, but of course not all of you are watching. It's going even further up. And yeah, we left it open for a while as we actually slowly move to the lunch break.
Yeah, thanks a lot for tuning in. And yeah, as mentioned, if you have any ideas, also don't hesitate to just shoot them over on LinkedIn. We are always open for input. You can either directly contact us, as you see here in the lower left and lower right corner, or you write to the AAIC, to the organizational page. So thanks a lot for tuning in, and see you in the afternoon sessions where we kick off with Martijn Leubers.
Just quickly, our contact details again, where you can find us. And yeah, we leave that up for a while, and we see each other in about 1 hour. Have a good lunch break.
Bye-bye.